Okay, so today we're going to be talking about algebraic equations. And to start out, we need to know this concept of the value of an expression. So an expression, just as a quick review, is a combination of numbers, variables, and operators on those numbers and variables. And so an example of a couple could be 14 minus 2, or 3 times the quantity 4 minus 1 plus 5. And what we can do with each of these is that we can evaluate them. So 14 minus 2 is going to be equal to 12. The value of 14 minus 2 is 12. We can do the same with 3 times 4 minus 1 plus 5. So we have to do the parentheses first. So this is 3 times 3 plus 5. 3 times 3 is 9 plus 5 is 14. So the value of this expression is 14. With that in mind, we can start to equate two expressions, or show that two expressions have the same exact value. So we talked about earlier that 14 minus 2 has the value 12, so it's equal to 12. Similarly, we said, okay, we evaluated this and said it was equal to 14. Well, 14 is also equal to 7 times 2, so we know that this first expression and the second expression are equal to each other. So we can use the equal sign to express when two expressions have the same value. Now, there's kind of a useful metaphor here where we can have scales. We can have some weights on one side, some other weights on the other side, and when these weights are balanced, when the scale is balanced, they're equal to each other. This is just a useful way to visualize equations. But something that we want to know is, okay, what happens when we have unknowns in our equations? For example, x, the variable x. So for example, in this situation, we have a left side of the equation, which we're expressing with the left side of our scale, and the right side of the equation, which we're showing in the right side of the scale. So here we have this plus 5 here, which we're going to represent with 5 1 kilogram weights that equal 5. Essentially, this is what 5 is. And to that, we add x. And then we have to think, okay, how are we going to show what x is? What we can do is we can say we have one weight of weight x kilograms, and we don't know what x is. It's some unknown weight. So that's what x is. So x plus 5 is shown right here on the left-hand side of the scales. And these weights are balanced, and then on the right-hand side, we'll have 7 1 kilogram weights. And that's how we would represent this equation, x plus 5 equals 7. The question is, how then do we figure out what x is? This weight here, what is the value of that? Well, really we want just to have x on one side of the scale and then all the weights on the other side of the scale, so that we can say, oh, these two weights are equal. The weight on the left-hand side is equal to the weight on the right-hand side. And we know how much weight is on the right-hand side, so x has to be equal to this particular amount. That's the idea here. So we really want to get rid of these 5 weights. If we do that, however, the left-hand side is going to get lighter, and so these scales will be unbalanced. This will be heavier, this will go up because it is lighter. So we can't just get rid of those 5 weights. We can get rid of them, but then we would also have to get rid of an equal amount of weight on the right-hand side as well. So we just crossed out 5 weights. So we can cross out 5 weights here as well. And then the scales would remain balanced. We've taken away the same amount of weight on the left-hand side as we have on the right-hand side. And so the scales should still be balanced. And then we will get x alone, just the single x kilogram weight, and we are left with 2 1 kilogram weights on the right-hand side. So from that, we can say that x is equal to 2. We can also plug that back into our original equation to double check our work. So if x equals 2, then we are saying 2 plus 5 should be equal to 7. Well, 2 plus 5 is 7, so this statement is true. So we kind of double checked our work, which is nice. But what do we do functionally to actually take away that weight from the left-hand side? We had this equation x plus 5 equals 7, And what we actually did is we took away 5 weights. But we did the same to both sides so that we would keep the weights balanced. 5 minus 5 is 0, so this goes away. And then we can just think about doing 7 minus 5, which is 2. So we got the same answer just by subtracting off the 5 that was being added to the x. Similarly, let's say instead of x plus something equals another value, we have some problem where x is being multiplied by a number. So in this case, we have 2x equals 10. We can visually represent that with 2 x kilogram weights on the left-hand side and 10 1 kilogram weights on the right-hand side. The weights are balanced, or the scales are balanced rather, so we can assert that these are equal to one another. And we can't, in this situation, just take away x, right? We want to get x on its own, but if we just take away x, then we don't know how much weight to take away here to keep our scales balanced. However, we know that we can split this in half, the weight in half, and that is something we can actually do, because if we split this weight in half, then we need to split this weight in half to keep them balanced. So we take half of the 1 kilogram weights here. So how many of them there are? There are 10. Half of 10 is 5, so we want to leave only 5. So we've crossed off 5, there should be 5 left. And now we know that x is equal to 5, because we have 1 x kilogram weight, and we're asserting that that's equal to 5 1 kilogram weights. Functionally, what we did is we just took 2x equals 10, and we said, oh, let's divide this by 2 on both sides of our equation to keep this balanced. Well, 2 divided by 2 is 1, so we're going to be left with 1x. 10 divided by 2 is 5, and 1 times x is really just x, so we're left with x equals 5. Kind of a similar process as when we added 5 to our x kilogram weight. So that's all fine and dandy, but sometimes you don't want to draw out scales to logic your way through this. You kind of want a general step-by-step process for how to solve these equations. And our goal, what we were doing implicitly, was to get our unknown, which in our case was x, on one side of the equation and all the other numbers on the other side of the equation. That results in us having some statement x equals blank, and then we can evaluate the expression on the right-hand side for some actual number, and we'll know the value of x at that point. That's the goal, to get x by itself on one side of the equation and all the numbers on the other. How do we do that? Well, what we were doing before is we were actually step by step identifying what operation is being done to x, and then doing the inverse of that operation to both sides of the equation. And then we repeat this over and over again until the goal is achieved. So for example, x divided by 4 is equal to 2. What operation is being done to x? That's the first thing we want to ask ourselves. Well, it's being divided by 4. So then we want to say, what is the inverse of dividing by 4? Well, the opposite operation of division is multiplication, so we should multiply by 4. So we'll do this here. We'll multiply by 4 on the left-hand side, but again, if we do it to the left-hand side of the equation, in order to keep the equation equal on both sides, we have to do it to the right-hand side as well. And then we have 4 times x over 4. Well, that's really like doing 4 divided by 4, which is equal to 1, so we can just kind of cross these out. We can cancel them out. So we'll be left with x on the side of the equation. And then on the right-hand side, we have 2 times 4, and 2 times 4 is 8. So the solution to this equation is going to be x equals 8. Now let's look at a slightly more complicated problem. In this situation, we're not just multiplying 2 times x and then having some number on the right-hand side, but we're also adding to the left-hand side where the x is, which makes things a little bit more complicated. So if we imagine this, we have 2 x kilogram weights on the left-hand side. We have 3 1 kilogram weights as well on the left-hand side. And the scales are balanced between that and 13 1 kilogram weights on the right-hand side. Okay, well, we can't just divide by 2 here and have x equals blank, because what that would mean is that we're still going to have these 3 here. If we divide this by 2, we're actually not accounting for the extra 3 weights here. and our scales will be unbalanced. So that's kind of unfortunate. I think the easiest way to approach this is actually to handle the 3 kilogram weights first. So we have the 3 kilogram weights here, and we want to get rid of them. But if we get rid of them, we also have to get rid of them on the right-hand side of the equation as well. So let's get rid of 3 1 kilogram weights, and to keep the scales balanced, we'll also get rid of 3 1 kilogram weights on the right-hand side. Well, now we just have 2 x's and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1 kilogram weights. So our equation has really become 2x equals 10. Well, we know how to solve this. We just split both sides in half. So we split the weight here in half, and then we split this in half. So we do 1, 2, 3, 4, 5. Take 5 weights away because half of 10 is 5. And we'll be left with x equals 1, 2, 3, 4, 5. X equals 5. Okay, again, that shows us how we do this process with our weight visualization. But let's say we just kind of want to do it straight from the equation itself. This here. Well, the first thing that we did was we asked, what is happening to x? And usually as a general guide, I like to work from the thing that is farthest from x while still being on the same side of the equal sign and work closer to x. So the thing that is farthest from x is the 3. So we're adding 3. So what operation is being done to x? We are adding 3. And really it's being done to 2x, but it's the furthest thing. And so if we're adding 3, the opposite operation of addition is subtraction. So we'll subtract 3 from both sides of the equation. These will cancel out, and we'll be left with 2x here. So we'll have 2x equals 13 minus 3 is 10. And now what operation is being done to x? It's being multiplied by 2. So we can divide both sides by 2. This will cancel out, and we'll be left with x all by itself being equal to 5. So x equals 5 is the solution to the equation 2x plus 3 equals 13. Let's do a quick practice problem just without our weight visualization as well. So again, I like to start with whatever operation is being done to our expression that's farthest from x but is still on the same side of the equation of it. And so here, the minus 5 is farthest from x. So we want to undo that. So the opposite of subtracting 5 is adding 5. So we'll add 5 to both sides of the equation. This will cancel out. We're left with our 4x here. And 11 plus 5 is 16. Now we only have one operation being left that is being done to x, which is multiplying by 4. The opposite of multiplication is division. So we'll divide both sides by 4. This will cancel out, and we'll be left just with x. And then 16 divided by 4 is 4. So the solution to our equation is x equals 4.